Hello everyone, I'm Anushree talking to you today about two serious issues faced by researchers worldwide: energy crisis and polluting emissions. Solution can be one: green hydrogen, highly energy dense and leaves no carbon footprint, generated by sunlight, splitting water photocatalytically. That is, water can be split into hydrogen and oxygen, getting hydrogen as a clean fuel and no polluting emissions of any greenhouse gases whatsoever. Since water splitting is an uphill reaction requiring energy, we use a photocatalyst that can make this reaction spontaneous. This photocatalyst functions by absorbing photons from sun and exciting the electrons from its valence band to conduction band, and then using these electrons at the surface to reduce protons from water to hydrogen. My photocatalytic material is nitrogen rich graphitic carbon nitride, that is C3N5, composited with amorphous MOS2 as a co-catalyst. Since both MOS2 and graphitic C3N5 have negative zeta potential, I first modified carbon nitride by an organic linker to convert its zeta potential to a positive value so that the composite can be formed by strong electrostatic attraction between them without separating into two different phases. Once the physical stability was ensured, I performed characterizations like ATR, XRD, and XPS, which confirmed the successful formation of composites with various loading percentages of MOS2 on GC3 and 5. Expected functional groups, diffraction patterns of crystalline planes, and elemental peaks in the XPS survey spectrum were obtained. UVDRS study confirmed a higher photonic harvest, and PL study exhibited less charge carrier recombination in the composite. We then performed PEC and found in transient current experiment the 5% loading of MOS2 on GC3 and 5 gives the highest amount of current as soon as the solar simulator is switched on. Nyquist plot shows this ability is due to least resistance of charge migration in this particular composite. Armed by this knowledge that the photosensitivity and photoconductivity of my composite is high, I performed HER under solar simulator and found encouraging value of 1184.4 micromoles per gram per hour. Buoyed by this experiment, I then performed it under direct sunlight and obtained three times more oxygen. I can confidently claim that my composite of graphitic C3 and 5 and MOS2 is a positive step towards the production of green hydrogen